So if you already know Python, you can probably skip the next two lectures, but if you need a refresher or if you haven't done Python before, you want to go through these. There's a few quirky things about the Python scripting language that you need to know about. So let's dive in and just jump into the pool and learn some Python by writing some actual code. All right, time for a crash course in Python. Now, like I said before, in the requirements for this course, you should have some sort of programming background to be successful in this course. You've coded in some sort of language, even if it's a scripting language, JavaScript, I don't care what it is, C++, Java, something. But if you're new to Python, I'm going to give you a little bit of a crash course here. I'm just going to dive right in and go right into some examples here. There's a few quirks about Python that are a little bit different than other languages you might have seen, so I just want to walk through what's different about Python from other scripting languages you may have worked with. And the best way to do that is by looking at some real examples, so let's dive into some code. All right, let's dive right in and look at some Python code. So if you open up the resources for this class that you downloaded earlier in the course, you should find a Python 101 file. So go ahead and double click on that, and it should open right up in Canopy if you have everything installed properly. And it should look a little bit something like this. So one cool thing about Python is that there is several ways to run code with Python. You can run it as a script like you would with a normal programming language. You can also run it in this thing called IPython Notebook, which is what we're using here. So it's this format where you actually have kind of a web browser view here, where you can actually write little notations and notes to yourself in HTML markup stuff. And you can also embed actual code that really runs using the Python interpreter. So here's an example. First example I want to give you some Python code is right here. So this gray block of code represents some real Python code that we can actually run right within this view here. So let's take a look at what's going on. We have a list of numbers, and a list in Python, kind of like an array in other languages, is designated by these square brackets. So we have this data structure of a list that contains the numbers 1 through 6. And then to iterate through every number in that list, we're going to say for number in list of numbers. That's the Python syntax for iterating through a list of stuff in a colon. And the point I want to make here is that in other languages, it's pretty typical to have a bracket or a brace or some sort there to denote that I'm inside a for loop or I'm inside an if block or some sort of block of code. But in Python, that's all designated with white space. So the tab is actually important in telling Python what's in which block of code. Okay, tabs have real meaning. Whitespace has real meaning in Python, so you can't just format things the way you want to. You have to pay attention to it. So you'll notice that within this for block, we have a tab of 1 within that entire block. And for every number in list of numbers, we will execute all of this code that's tabbed in by one tab stop. We're going to print the number, and the comma just means that we're not going to do a new line afterwards. We're going to print something else right after it. And if the number modulus 2 is equal to 0, we'll say it's even. Otherwise, we'll say it's odd. And then when we're done, we'll print out all done. And you can see here I ran the output before, and it actually saved it within my notebook. But if you want to actually run it yourself, you can just click within that block and push the play button, and we'll actually execute it and do it again. And just to convince yourself that it's really doing something, let's change the print statement to say something else. Say, hooray, we're all done. Let's party. And if I run that now, you can see, sure enough, my message there has changed. So again, the point I want to make there, white space is important. You will designate blocks of code that run together, like a for loop or if-then statement, using indentation, using tabs. So remember that. Also, pay attention to your colons here too. You'll notice that a lot of these clauses begin with a colon before. Next thing I want to cover is importing modules. So Python itself, like any language, is fairly limited in what it can do. The real power of using Python for machine learning and data mining and data science is the power of all the external libraries that are available for it for that purpose. One of those libraries is called NumPy, or Numeric Python. And for example here, we can import the NumPy package, which is included with Canopy, as NP. That means I'm going to refer to the NumPy package as NP, and I could call that anything I want. I could call it Fred, I could call it Tim, but it's best to stick with something that actually makes sense. And then now that I'm calling that NumPy package NP, I can refer to it using NP. So in this example, I'm going to call the random function that's provided as part of the NumPy package and call its normal function to actually generate a normal distribution of random numbers using these parameters and print them out. So go ahead and show you that that actually works. And since it is random, I should get different results every time. Sure enough, I do. So that's pretty cool. Just the point there, again, we need to import stuff. You'll see a bunch of import statements up the top, and that's what's going on there. And if there's an as statement, that means that we're going to actually refer to that package as some different alias. Let's move on to data structures. If you need to pause and let things sink in a little bit, or if you want to play around with these a little bit more, feel free to do so. You know, the best way to learn this stuff is to dive in and actually experiment. So I definitely encourage doing that. And that's why I'm giving you working IPython notebooks so you can actually go in, mess with the code, do different stuff with it. You know, for example, here we have a distribution around 25, but, you know, let's make it around 55. Hey, all my numbers changed. They're closer to 55 now. How about that? All right, let's talk about data structures a little bit here. So as we saw in our first example, you can have a list, and the syntax looks like this. You can say, call a list X, for example, and assign it to the numbers 1 through 6, and these square brackets indicate that we are using a Python list, and those are immutable objects that I can actually add things to and rearrange as much as I want to. There's a built-in function for determining the length of a list called len, and if I type in len X, that will give me back the number 6 because there are 6 numbers in my list. You know, just to make sure, just again to drive home the point that this is actually running real code here, let's add another number in there, like 400 and whatever it is, 4,545. If we run that, we'll get 7 because there's now 7 numbers in that list. Go back to the original example there. Now you can also slice lists. If you want to take a subset of a list, there's a very simple syntax for doing so. So for example, if you want to take the first 3 elements of a list, elements is everything before element number 3, we can say :3 to get the first 3 elements, 1, 2, and 3. And if you think about what's going on there as far as indices go, like in most languages, we start counting from 0. So element 0 is 1, element 1 is 2, and element 2 is 3. So since we're saying we want everything before element 3, well, that's what we're getting. So, you know, never forget that in most languages you start counting at 0 and not 1. It can confuse matters, but in this case it does make intuitive sense. You can think of that colon as meaning I want the first 3 elements. And I could change that to 4, and you know, just to again make the point that we're actually doing something real here. Now if I put the colon on the other side of the 3, that says I want everything after 3. So 3 and after. So if I say x3 colon, that's giving me the 3rd element, 0, 1, 2, 3, and everything after it. So that's going to return back 4, 5, and 6 in that example. Okay. You might want to keep this IPython notebook file around as a good reference because sometimes it can get confusing as to whether the slicing operator includes that element or if it's up to or including it or not. So best way is to just play around with it here and remind yourself. One more thing you can do is have this negative syntax. So by saying x bracket -2 colon, that means I want the last 2 elements in the list. Okay, so that means go backwards from the end, and that will give me 5 and 6 because those are the last 2 things in my list. You can also change lists around. So let's say I want to add a list to the list. I can use the extend function for that. So I have my list of 1, 2, 3, 4, 5, 6. If I want to extend it, I can say I have a new list here, 7, 8. And that bracket indicates this is a new list of itself. So that could be a list implicit, you know, that's in line there. It could be referred to by another variable. But you can see that once I do that, the new list I get actually has that list of 7, 8 appended onto the end of it. So now I have a new list by extending that list with another list. If you want to just add one more thing to that list, you can use the append function. So I just want to stick the number 9 at the end. There we go. And you can also have complex data structures with lists. So you don't have to just put numbers in it. You can actually put strings in it. You can put numbers in it. You can put other lists in it. It doesn't matter. Python is a weakly typed language, so you can pretty much put whatever kind of data you want wherever you want, and it will generally be an okay thing to do. So in this example, I have a second list that contains 10, 11, 12 that I'm calling y, and I'm going to create a new list that contains 2 lists. So how's that for mind-blowing? Our list of lists will contain the X list and the Y list, and that's a perfectly valid thing to do. And you can see here that we have a bracket indicating the list of lists list, and within that we have another set of brackets indicating each individual list that is in that list. So sometimes things like that will come in handy. If you want to dereference a single element of a list, you can just use the bracket like that. So y bracket 1 will return element 1. Remember, y had 10, 11, 12 in it, and we start counting from 0, so element 1 will actually be the second element in the list, or the number 11 in this case. All right. And finally, lists have a built-in sort function you can use. So if I start with a list z, which is 3, 2, and 1, I can call sort on that list, and z will now be sorted in order. There's also, if you do need to do a reverse sort, you can just say reverse equals true as a attribute, as a parameter in that sort function, and that will put it back to 3, 2, 1. All right. If you need to let that sink in a little bit, hit pause, feel free. Go back and play a little bit more. We're going to move on to our next concept. Tuples are just like lists, except they're immutable. So you can't actually extend them or append them or sort them. They are what they are. And they behave just like lists apart from the fact that you can't change them, and you indicate that they are immutable and are a tuple as opposed to a list by using a parenthesis instead of a square bracket. So you can see they work pretty much the same way otherwise. I can say x equals paren 1, 2, 3. I can still use length on that to say there's 3 elements in that tuple. And even though, if you're not familiar with the term tuple, a tuple can actually contain as many elements as you want. Even though it sounds like it's Latin based on the number 3, it doesn't mean you have 3 things in it. Usually it only has 2 things in it, and it can have as many as you want, really. We can also dereference the elements of a tuple. So element number 2, again, would be the third element because we start counting from 0, and that will give me back the number 6 in this example. We can also, like we could with lists, use tuples as elements of a list. So we can create a new list that contains 2 tuples. So in this example, we have our x tuple of 1, 2, 3, our y tuple of 4, 5, 6, and we make a list of those 2 tuples, and we get back this structure where we have square brackets indicating a list that contains 2 tuples indicated by parentheses. And one thing that tuples are commonly used for when we're doing data science or any sort of processing of data, really, is to use it to assign variables to input data as it's read in. So I want to walk through a little bit what's going on in this example. Let's say we have a line of input data coming in, and it's a comma-separated value file, and it contains ages, comma delimited by an income for that age, for example, just to make something up. What I could do is, as each line comes in, I could call the split function on it to actually separate that into a pair of values that are delimited by commas. And what I can do is take that resulting tuple that comes out of split and assign it to 2 variables all at once by defining a tuple of age income and saying I want to set that equal to the tuple that comes out of the split function. So this is basically a common shorthand you'll see for assigning multiple fields to multiple variables at once. So if I run that, you can see that the age variable actually ends up assigned to 32 and income to 120,000 because of that little trick there. Now, you do need to be careful when you're doing this sort of a thing, because if you don't have the expected number of fields, the expected number of elements in the resulting tuple, you will get an exception if you try to assign more stuff or less stuff than you expect to see here. All right. Finally, the last data structure that we're going to see a lot of in Python is a dictionary, and you can think of that as a map or a hash table in other languages. So it's a way to basically have a little sort of mini database, sort of a key value data store that's built into Python. So let's say I want to build up a little dictionary of Star Trek ships and their captains. So I can set up a captains equals curly brackets, where curly brackets indicates an empty dictionary. Okay, and now I can use this sort of a syntax to assign entries into my dictionary. So I can say captains for Enterprise is Kirk, for the Enterprise D is Picard, Deep Space Nine, Cisco, Voyager is Janeway. And now I have basically this lookup table that will associate ship names with their captain. And I can say, for example, print captains for Voyager, and I get back Janeway. So a very useful tool for basically doing lookups of some sort. You know, let's say you have some sort of an identifier in a data set that maps to some human readable name. You'll probably be using a dictionary to actually do that lookup when you're printing it out. We can also, so what happens if you try to look up something that doesn't exist? Well, we can use the get function on a dictionary to safely return an entry. So in this case, Enterprise does have an entry in my dictionary, and it just gives me back Kirk. But if I call the NX-01 ship on the dictionary, I never defined the captain of that, so it comes back with a none value in this example, which is better than throwing an exception, but you do need to be aware that that is a possibility. It's Jonathan Archer, but I'm getting a little bit too geeky here now. Little example here of iterating through the entries in a dictionary. So if I want to iterate through every ship that I have in my dictionary, print out their captions, I can go for ship in captains, and that will iterate through every single key in my dictionary. And then I can print out the lookup value of each ship's captain, and that's the output that I get there. So there you have it. And that's basically the main data structures that you'll encounter in Python. There are some others like sets, but we're not going to really use them in this course. So I think that's enough to get you started. Let's dive into some more Python nuances in our next lecture.